All right, so first up is complex lipids, right? We said all of these have esters and can be hydrolyzed. So the first type are waxes. They have various purposes. Again, not that important in humans, but more important in plants and animals, or plants and bugs, that kind of thing. So they're basically just an ester, right? We've got two of these R groups, and both of these R groups are long hydrocarbon chains. Think, 20 plus carbon longs. And so that can, kind of tell you about the properties. They're like waxy, right? They're going to have a relatively high melting point just because they're so long and that kind of stuff, right? A lot of dispersion forces, that kind of thing. Next up are triglycerides, which are more important to us because we're kind of humans. They're kind of what we think of when we say fat, right? One of their main purposes is energy storage. And it's triglyceride because they're derived from glycerol. And then there's 3 fatty acids. So glycerol is this compound right here. It's 3 carbons, 3 alcohols. And you can think, right, glycerol obviously is going to have a pretty high melting and boiling point due to all the hydrogen bonding it has, that kind of thing. So there's our glycerol, and then it comes with 3 fatty acids. They're called acids because they have a carboxylic acid on them. Right, and again, here R is some kind of long hydrocarbon chain. In both waxes and these fatty acids, these hydrocarbon chains generally are not branching, so they're just straight chain. Anyways, they combine together. Alcohol plus carboxylic acid equals ester. And then when I think about esters, the chemistry of esters, you can hydrolyze them using acidic or basic conditions. You can do all kinds of cool things with them. And then finally here we have phosphoglycerides. So, right, it's like a glyceride, except now it's going to have a phosphate group there. So it's good, at least some of this nomenclature makes sense. So we have phosphorus, and then 1 doubly bound oxygen, and then 2 singly bound oxygens. And what's on these oxygens depends. Sometimes you'll see an H on them. Sometimes you'll just see a straight up negative charge on them. So put or negative charge, that's more likely in a physiological pH range. Or they could be some other kinds of groups. So for example, they could be ethylamine, ethanolamine. And of course, in physiological ranges, this nitrogen would then become protonated. Or also commonly choline, which looks like this. Right, so that's what they look like. You can see they have charges, they have polarity, and we'll see how that plays a role in the phospholipid bilayer, or just the lipid bilayer.